Hey everyone, good morning. I'm Pranshi Agrawal and welcome back to my YouTube channel. Now we are going to solve today's Leetcode daily challenge, which is product of the last k numbers. Okay, so let's see what is this question and how we can solve it. So in this question, you need to design an algorithm that accepts a stream of integers and retrieves the product of last k integers of the stream. Okay, you need to implement the product of numbers class, that is product of numbers, its constructor. It means initializes the object with an empty string. Void add appends the integer num to the string. Int get product returns the product of the last k numbers in the current list, and you can assume that always the current list has at least k numbers. Okay, and the test cases are generated so that at any time the product of any contiguous sequence of numbers will fit into a 32-bit integer without overflowing. Okay, so let's see. You have been given with a class product of numbers and you need to implement two functions, void add and get product. Add will add the integer to the stream and get product will return the product of last k in numbers. Okay, so let's see this example. Okay, so in this example, first you are asked to add 3. Okay, so you add 3 to the stream, or we can say we have created a vector. Okay, then you are asked to add 0. Okay, added. Then you are asked to add 2. Okay, added. Then you are asked to add 5. Okay, added. Then you are asked to add 4. Okay, added. And then you are asked to get the product of last two numbers, that is 5 and 4. So you can simply return the product of 5 and 4, that is 20. And then you are asked to return the product of last three numbers, that is 2, 5 and 4. So their product is 40. And then you are asked to return the product of last four numbers, that is 0, 2, 5 and 4. So their product will be 0. And then you are again asked to add 8. Okay, added. Then you are asked to return the product of last two numbers. Okay, so these are 4 and 8, so it will be 32. Okay, so I think you can derive the brute force approach from here is that you need to create a vector and then you can keep on pushing the elements at the end of the vector, right? So the adding the element in the end of the vector complexity is big of 1. Okay, and then you need to get the product of last k numbers from the vector, so its complexity will be big of k, right? This will be the complexity of add function and this will be the complexity of get product function. Okay, and these are the time complexities, and the space complexity will be big of n, right? Because we will end up storing all the numbers. So these will be the time and space complexities. But you are already given in the question that can you implement both the functions in big O of 1. Okay, so let's see if we can implement both the functions in the big O of 1 complexity. So you are given that you need to access the last k numbers to get their product. Okay, so when when there is a particular number of digits you need to access, then you can think of a sliding window approach or a prefix sum, right? Okay, in the prefix sum what we do is let's say we have these numbers 1 2 3 4 5 and 6, right? And we need to find the sum of three numbers, right, in the sliding window approach. So let's say we will first find the sum of three numbers, this, and then three consecutive numbers, and then we will slide this window. Let's say we will add the 4 in our current sum and we will subtract the 1 from our current sum, and our current sum was 3 plus 2 plus 1, that is 6, minus 4, sorry, plus 4 minus 1. In this way we will keep on changing our window size, right? Okay, so how we can implement this prefix sum or sliding window approach here? Can we use the sliding window approach in this current question? No, because in the sliding window approach the k is a constant, but in this question you can see that k is a variable. You will be given with a new value of k every time. So we can't use the sliding window approach here because k value is varying. So can we use the prefix sum approach here? Okay, it means prefix product approach here, because in this case we need to find the product of k numbers. Okay, so let's see. Initially we have prefix product, let's say pp, and then we will store it there as 2 multiplied by 1 2, 3 multiplied by 2 6, 6 multiplied, let me write it as also so that you will not get confused, 6 multiplied by 4 24, 24 multiplied by 1 24, 24 multiplied by 2 48, and 48 multiplied by 1, that is 48. Okay, so now let's say you are asked to find the multiplication of last three numbers. Okay, so what you can do, let's say the size of the current vector is 7, right? The size of current vector is 7. So we will access the product, last product, and size minus k, here k is 3, minus 1, that is 7 minus 3 4, minus 1 3. Then let me just also write the indexes 1 2 3 4 5 and 6. So the index 3 value is 24. So 48 divided by 24 is 2, and you can see the product of last three numbers is 2. Okay, so we can use the prefix product approach here to find the product of last k digits, but here is a catch. In the case when our digit is not 0, you can see here the numbers are not 0, but number can also be a 0. Okay, what happened if number was 0? Okay, let me just write it here. Okay, let's see, 1 2 0 1 2 3. Okay, now let me also write the indexes 0 1 2 3 4 5. If the number was 0, then what would have become? This is 1, this is 2. Okay, but this will become 0, and all the consecutive prefix product will become 0. And now we are not, and now when we try to access this number, then this will be 0. And let's say we need to again find the product of last three numbers. So here size is 6 minus 3 minus 1, that is 2. This. Now we will divide the 0 by 0. So this 0 is fine. We can divide as 0, but we can't divide the number by 0. So it will give us runtime error. So here 0 can create a problem. So we just need to handle the case when a number can be 0. Okay, so let's see how we can handle the case when a number is 0. Okay, let's see how we will handle it. We just need to handle one case here. Okay, so whenever there is 3 3, okay, in the current example also you have been given with a 0 in the stream. Okay, so whenever 0 comes, you know that the product before this is going to be 0 if we are taking 0 in the product, right? Okay, so what we can do is we can simply replace it by 1, because if the 0 occurred in the stream, then obviously we are if we are taking the numbers before this, then obviously we are taking 0 as 2, right? So if we take 0 in the product, then obviously the product is going to be 0. So we will set it as a default value. So the default value for multiplication is 1 and addition is 0. Okay, so we will set it to default value. Okay, now let's see. Now again we need to add 2. Okay, now we are again need to add 5. Okay, 1 2 5. Now we need to add 4. 1 2 5 and 4. Okay, now we are asked to get the product of last two numbers. Okay, so what we can do is we can simply, we need to store the prefix product. Okay, let me just store the product. So this will become 10, and then this will become 10, and 10 multiplied by 4 40. Okay, now we are asked to get the product of last two numbers. So what we will do, 40 divided by size is 4, 4 minus 2 minus 1, that is 1, 1 is 2. Okay, so we will divide by this, so we will get the product as 20. So as you can see, 5 4s are 20. Okay, now let's get the product of last 3 numbers, that is 1 2 10 and 40. Okay, 40 divided by size is 4 minus k is 3 minus 1, so this is 0. Okay, and 0th index value is 1, so the product is 40. Yeah, product is 40. Okay, now get the product of last 4 numbers. Okay, let's see. So 40 divided by size is 4 minus k minus 1. Oh, now we are trying to access a value, access an index which doesn't exist. It means we have encountered a 0 in our multiplication. As you can see, we have encountered a 0 in our multiplication, and we are trying to access an index, that is size minus k minus 1 is less than 0. If this is true, it means we have encountered a 0 in our multiplication and its answer will be 0. Got it? How we have entered the case of 0 is that we are setting it as default value, and if the size minus k minus 1, it means the prefix index which we are trying to access doesn't exist. It means we have reset its value because it was 0. It means our multiplication of k digits will be 0. Okay, now let's further iterate. 1 2 10. Now we need to add 8, that is 320. Now we need to access the last 2 numbers, product of last 2 numbers. So that is 320 divided by, now size is 5 minus 2 minus 1, 5 minus 3 2, that is 10. So the product is 32. So it is 32. So got it? How we are handling the case of 0. If there is no 0, then it's fine, it's very easy. But how we need to handle the case of 0? We need to first set its default value as 1, and then if size minus k minus 1 doesn't exist, it means we have encountered a 0 in our stream and we need to return 0. Okay, so let's try code this. So first we need to create a vector, let's say prefix plot, and let's initialize it with the default value. And if num is equals to 0, then what we will do? We will simply reset it to 1, right? Otherwise what we will do? We will simply push the product. Prefix plot dot push back prefix plot dot back multiplied by num, right? Okay, and now in get product what we need to do is let's store the size of the prefix plot dot size, and if size minus k minus 1 is less than 0, then what we will do? We will simply return 0. Otherwise we can calculate the product of last k numbers, that is prefix plot of size minus 1 divided by prefix plot of size minus k minus 1, and we will simply return product. Okay, let's try run this. So yeah, it's working fine. Let's try submitting it. Yeah, it's working fine. So now let's talk about its time and space complexities for this approach. So as you can see, the complexity of add function will be big O of 1, as we are just pushing the elements at the end of the vector, and the complexity of get product function will also be big O of 1. As you can see, we are just accessing the prefix plot size minus 1 and prefix plot size minus k minus 1, right? So the complexity of get product function will also be 1, and space complexity will be big O of n, as we have used this extra space. So yeah, this was all for this question. I hope you get it, but if you still have any doubts, then you can post in the comment section. I will surely try to answer them. Till then, bye guys, see you in the next video.